do the following integrals. So we have the integral of 3x squared plus 8x minus 5 dx. Now let's remember that the integral of ax to the n dx is, the a is just a constant, so it doesn't actively integrate. We increase the power by 1, divide by the new power, and we have an arbitrary constant. And we don't have a different arbitrary constant for each one, we'll just have a single arbitrary constant at the end. So this one is going to be 3x cubed divided by 3 plus 8x squared, remember this is x to the 1, divided by 2. And then if we think about the 5, that's actually 5x to the 0, because we know x to the 0 is 1. So that's going to become 5x to the 1 over 1, and plus a constant, and then all we need to do is tidy. So that's x cubed plus 4x squared minus 5x plus c. Now with this next one, we could expand out and do exactly the same thing. But this is an example of where we can use reverse chain. Now, reverse chain in quotes because it's not a real thing. You'll speak to lots of mathematicians, they'll have no idea what you're on about with reverse chain. So just follow me on this one for a moment. If you think about the differentiation chain rule, if we had 3x minus 2 to say the 7, we can differentiate that by doing 7, 3x minus 2 to the 6, so we differentiated the outside function, then we multiply by the differential of the inside function. So we can reverse chain by increasing the power, divide by the new power, but also, remember the opposite of multiply is divide, divide by the differential of the inside function. We can only do this if the differential of the inside function is a constant. So when we come to part C, we're not going to be able to reverse chain because when we differentiate the inside, it's a function of x, not a constant. So let's do it that way. 3x minus 2 cubed divided by 3, but then we have to multiply by the differential of the inside. Sorry, we're going to divide by the differential of the inside, so what I meant was multiply on the bottom, and the differential of the inside is 3, and then we add a constant. So that's 3x minus 2 cubed over 9 plus a constant. Now with this one, as we said, we can't do that because the differential of the inside is not a constant, so we'll have to actually expand out. So that's going to be x squared minus 2x, x squared minus 2x, like so. So that's going to give me x to the power 4 minus 4x cubed plus 4x squared, and then that's x to the 5 over 5 minus 4x to the 4 over 4 plus 4x cubed over 3 plus a constant, and we'll just tidy up, so that's x to the 5 over 5 minus x to the 4 plus 4x cubed over 3 plus a constant. So really note the difference here. If the differential of the inside is a constant, we can reverse chain. If it isn't, we cannot. Now of course we can do these on the calculator, so let's just look at that. So if we go into keyboard and Math 2, all of our various integrals are here. we'll just choose this one, and don't worry about the boxes, we'll look at that later. And so if in here I have 3x minus 2 squared, and we differentiate that with respect to x. Sorry, we're integrating with respect to x, and I've got 3x minus 2 cubed over 9. The calculator doesn't put the plus c on it, so don't worry about that. Now let's try this one here and see what that does. So that's going to have x squared minus 2x, and that is all going to be squared, and we're doing that with respect to x. And note that it's done it in the sort of expand out way that I did as well. So the calculator recognizes when you can reverse chain and when you can't.